Now the next version of the if statement is if come with the else. Now if the condition is true, then the following statements are executed. Else, if the condition is false, then the else statements are executed. Now here I have shown the two forms of an if else statement. If you are coming with a single statement, we can have if an expression within the rounded brackets and we can have a single statement. After that we can write down the keyword else, we can write down the single statement after that. The another way of using if else statement is that if expression within the rounded brackets, then you can have open parenthesis and we can write down the block of statements and then we can close the parenthesis. So this block belongs to the if. After that you can write down else, and with the open parenthesis you can write down the number of block of statements and you can close this by close parenthesis. Now this blocks belongs to the else statement. Now here I have shown the algorithm of an if and else. So where we have a condition if a is greater than 10. Now this condition is checked, and when this condition is checked, the answer is in the terms of true and false. So when I say the condition is true, it means it is yes. When I say condition is false, it means it's a no. So whenever the condition is true, the block of statements under the if statements are executed, and after that the next program code is executed. Now let us say if the condition is false, in that case the answer is no, then the block of statements under the else is being executed, and after that the next part of the program is executed. Now let us look at the looping statements. So looping statements are used to execute or to run the block of statement again and again until the particular condition is satisfied. In embedded C, we are having a three kind of loop statements. The first one is called as a while loop. The next one is called as a do while loop, and next to that one is called as a for loop. Now let us study these loops one by one. Now let us learn the first loop, which is a while loop. The syntax is very simple. The keyword while, and after that within the rounded bracket we have to write down the expression. Now whenever this expression is true, the block of statements will be executed again and again. So block of statements are written within open parenthesis and the close parenthesis. So at the first loop, the while loop looks very similar to that of if loop. But remember one thing, if loop can be executed only once, whereas the while loop can be executed again and again. So here I have shown you the situation where we have while a is greater than 10. If the answer is yes, the block of statement is executed, and again we need to check whether a is greater than 10. So whenever a is greater than 10, the block of statement is executed again and again. So when the condition is false and answer is no, the next part of the code is being. Now let us look at the next loop, which is called as a do while loop. So syntax is as shown in the PowerPoint. So it starts with the keyword do. After that it starts with the open parenthesis and we have to write down the block of statements, close parenthesis, and after that we have to write down a keyword while, and within a while we have to write down the expression. So in do while loop, what it does is it executes a block of statements and after that it checks whether the condition is true or false. So here in the algorithm I have shown it. So here we have the block of statements and then the condition is checked whether the while a is greater than 10 or not. If the condition is yes, this block of statements is executed again and again. Whenever the condition is false, the next block of the statement. Now let us look at the next looping statement, which is called as a for loop. So for loop starts with the keyword for, and it has three conditions written in the rounded brackets. So the first condition is called as an initialization condition. The second condition is called as a true or false condition, and the third condition or the third statement is given for incrementing or the decrementing while executing the for loop. To initialize the for loop, we have to set a counter. Let us say my counter is less than 10. In that case, if the condition is true, then the block of statements will be executed and the counter will be either incremented or the decremented, and after that it will again check the value of a counter. Still, if the counter value is less than 10, the block of statements is executed, and after that the counter will be either incremented or the decremented depending on the situation, and at one time this condition becomes a false, and in that case the next block of statements are executed. As shown in the slide, there are two type of for loops. with the single statement or with the multiple statements. So the for loop with the single statement can be write down for initialization conditions and the final conditions followed by the single statement. And if we have a block of statement, in that case what you can do is you can use an open parenthesis and a closed parenthesis, and within that you can write down the block of statements. In embedded C, we have one more concept which is called as a super loop. Now this super loop means it is an infinite loop, so it is executing continuously. So we can make this super loop by using either a for loop, or we can make this by using a while loop. So within a for loop, if we don't have initialization condition and the final condition, it will be treated as infinite loop because it will be executing forever. Whereas if you are using a while loop, and if you write down while and within the rounded bracket once, which is nothing but a true value, true forever, so this becomes a forever loop by using a while statement. Using a forever loop or the super loop is a common practice in embedded C. So this is a top loop within a program, and that is why it is called as a super loop. Now let us look at the different data types those are available in embedded C. Data type means a type of a data that we are going to use. So the data can be 8-bit, data can be 16-bit, or the data can be a 1-bit. In C language, the first data type is a char. So char is a 8-bit data type. So we can store 8-bit value into a char data type. So this char can be used as an unsigned char, in which we get the range from 0 to 255. So you can find out the range like 2 raised to 8, so that becomes 256. So we can have a number between 0 to 255. If we use a signed char, in that case the range becomes a smaller and it ranges from minus 128 to plus 128. Use integer data type, which is a 16-bit data type. Now here you can imagine that 2 raised to 16, we can have the numbers from ranging from 0 to 65,536 in a case of unsigned integer, and in a case of signed integer we can have a range from minus 32,700 to plus 32,700. Now let us see the data types in detail one by one. So first of all, we are going to look at the char, which is a 8-bit data type. So it has two types. One is called as unsigned char and the next one is called as a signed char. So let us look at the unsigned char first. So in unsigned char, it is of 8-bit data and it ranges from 0 to 255. So there are most of the physical parameters which are having only a positive values and which ranges between 0 to 255. So the first case is pH. So pH value always ranges from 1 to 14. So it is always positive. The next example I can take is a pressure value. So pressure is always positive value which ranges from 0 and above. So for such cases we can go with the unsigned. If you are constructing an instrument which measures the pH value, in that case you have to connect a pH sensor to an ADC, which will convert the pH value, which is an analog value, into a digital value. So all these digital values will be a positive values. Similar to that case of an, let us say, an pressure. In that case, we have to connect a barometer, which will give you an analog value, which will be converted into a digital value by an ADC. So all these values will be positive values, which will be read by your microcontroller, and the data type will be a unsigned char data type. Similarly, you can imagine that if you want to generate only a positive waveforms, in that case what you can do is you can give all those positive values to the digital to analog converter so that you will get a positive waveform. Let us say in my application I am interfacing LCD and the OLED display. In these cases I have to send a data as well as I have to send a command to them. All these commands or the data are positive in nature. Now let us look at the next data type, which is called as a signed char. This is also an 8-bit data type, but it ranges from minus 128 to plus 127. Let us say that in my application I want to measure the temperature. So the temperature may be a negative or may be a positive. In such cases I should go with a signed char. Now if the temperature ranges between minus 128 to plus 127, this signed char is suitable for measuring these kind of temperature. Or you can have a different kind of waveforms which has a positive values as well as a negative values. Such values can be measured by using an analog to digital. After the conversion, we'll get a positive values as well as a negative values.